In this lesson, we're going to work with numbers that have got bases with a negative index. So this would be something like a base of 3 with perhaps an index of -4. What do we do with these? Well, the first thing we're going to do is to have a look at applying the index laws to simplify a fraction like this, a to the power of 4 over a to the power of 5. Now we know that our index laws say that if the bases are the same, which they are in this case, then we subtract the indices. And when we simplify this down, we have a to the power of 4 minus 5, which is -1. So there we go, a negative index. Let's have a look at what we do when we expand a number like this, exactly the same number in fact. We go a times a times a times a, and underneath we have 5 of them, 1, 2, 3, 4 and 5. I'll just mark in here letter B. Alright, so let's cancel out. We know that if we divide out a into a, it goes once in each of these, and we can repeat this procedure right the way through. And what we're left with is all of these are 1s, 1 times 1, so we have 1 at the top, and all of these are 1, so it's 1 times a, and 1 times a is a. So in fact, our conclusion is, because we know that a to the 4 over a to the 5 is equal to a to the -1, and we get this from here, and we also know that exactly the same expression gives us 1 over a from here, then we can conclude that a number that has a negative power is the same as that very number written in the denominator with a positive power, or if you like, 1 over a. Here are some examples of how this works. In this case, you'll notice that there's a negative power here, so our rule simply says that you bring the base down underneath and it becomes a positive. It's a bit like a signal. When you see a negative in the index, you can write it as a positive as long as you put it into the denominator. So here we go again with this one. This would be 1, and the m would now be underneath because we want to change this to a positive. We can reverse this as well, so that if a number is in the denominator with a power, we can take it into the numerator, but we need to change the sign to a negative for the index. Likewise here, we're going backwards, I guess, in a sense, and we're going to move this to the top. So these are identical answers, just written in a different format. This one's got a positive index, but I can write it with a negative index as well. These are interesting examples because they almost look the same, and we've come across these before. But the main thing to remember is that if I expand these before working with them, you can see that the -2 only affects the m. It's m to the power of -2. So this would be 3 times. Now we apply our rule for negative indices here, so we get to this, and then we can actually multiply these together. 3 times 1 is 3, all over m squared. So what's the difference between this one and this one? Well, in this case, because the 3m is in brackets, both of these are influenced by the -2 index. So we would have to apply the rule to the whole bracket, and that whole bracket goes underneath and it becomes a number to the power of 2. Now it's probably worth noticing as well that in this particular case you can expand this out so that we know that 3 is to the power of 1 because we can't see a number there, and m is also to the power of 1 because we can't see a number there, and this is squared. And according to our rule, we need to multiply the 2 with this one and the 2 with this one. And this is what we get. 1 over 3 to the 1 times the power of 2. And then we've got m1 times the power of 2. And this will give us 3 squared, 1 times 2. And this will give us m squared. We can then simplify one more step. And we've got 3 squared, which would be 9, and m squared to finish it off.